Now we are starting question number 4 of this mechanics paper 1 9709 oblique 4 to May June 2023 is the code of this paper. And the question number 4 is an athlete of mass 84 kg is running up along a straight road. Initially, the road is horizontal and he runs at a constant speed of 3 meters per second. The athlete produces a constant power of 60 watt. Find the resistance force of that athlete which is acting on that road. Since the mass of that particle is 84 kg and that is a straight horizontal road, and they have given the velocity at a constant equal to 3 meters per second with a power 60 watts, we know that the power is basically equal to driving force into velocity. So from this, the driving force will be equal to power over velocity. Power is 60, velocity is 3, so that is 20 Newton. Now we know one thing, driving force minus resistive force is equal to net force MA. Driving force is 20 minus resistive force we are going to calculate is equal to mass into acceleration. But acceleration is 0 there because it is moving at a constant speed. So this will be 0. So resistive force is equal to 20 Newton for this particle there. Then for the next part, the athlete is going to run up a section of 150 meters on that road, which is inclined at 0.8 degrees to the horizontal. The speed of that athlete at the constant at the start of the section is 3 meters per second, and he produces a constant driving force of 24 Newton. The total resistance force on which acts on that particle is of that section on this road has a constant magnitude of 30 Newton. Using the energy method to find out the speed of this athlete at the end of the 150-meter section of that road. Since now he is going to move on an inclined plane at an angle of 0.8 degrees to the horizon. So this is 0.8 degrees to this horizontal. Let's say A to B is the total distance traveled, and that is of 150 meters from A to B. And there is a constant driving force which is equal to 24 Newton. There is a constant resistive force which is equal to 30 Newton. And we are going to find out the resistance force to that particle. The speed, the initial is 3 meters per second. And for the final, we have to calculate. So let's say the particle at this position. This is R, this is mg cos theta, this is mg sin theta, and this is the resistive force to that because it is moving in the upward direction, and that is the driving force of that particle. We know from the work energy principle that the work done by driving force minus work done by resistive force is equal to change in kinetic energy of the system. R, driving force is as it is. The resistive force is known. There are two types. One is the resistive force itself, and the other is mg sine theta into the distance between these two is 150, and that thing is equal to half m v square minus u square. So now work done by driving force is, the driving force is 24 into the distance between, work done by driving force is basically equal to 24 into 150. So we can produce all this into this equation number 1. Then this will become 24 into 150 minus resistive force is 24. So resistive force is 30 plus mg, m is 84, g is 10 into sine of 0.8 into 150 is the total distance traveled by that particle is equal to half mass is 84, v square is unknown, and u square is what? 3 square is 9. So after doing this all calculation, it should be equal to 24 into 150 minus 13 into 150 minus 840 sine of 0.8 into 150. That thing is equal to 42 v square minus 9. And after doing this calculation, we have calculated that v is equal to, so v is being calculated there equal to 2.53 meters per second. So this is the final speed of that mass of 84 kg athlete, which is running upward, making an angle of 0.8 degrees with the horizontal layer. In other words, or simply, work done by driving force minus work done by the frictional force is equal to half mv square minus u square, because it is moving upward, so it is gaining height, and you can find out this height also there. Same formula will be used, same calculation will be used, but it is in this form. You can write it in that equation there, where height is basically equal to so h over 150 is equal to sine of 0.8, or h is equal to 150 into sine of 0.8.